last but not least, let's talk about testing claims with confidence intervals. So we learned in the last chapter how to calculate confidence intervals. Now we're going to learn how to test claims with these confidence intervals. So a confidence interval, remember, is an estimate of a population parameter that contains the likely value of that parameter with some degree of confidence, okay? So we would therefore reject a claim that the population parameter has a value that's not included in our confidence interval, okay? So let's say I have a confidence interval that my population mean is between 2 and 6, and if I got a sample size, right, of less than 2 or more than 6, we would need to reject the claim. So if we have an alpha level of 0.05, then we construct a 95% confidence interval. Remember, our confidence interval plus our alpha is 1. And if our supposed population mean was not included in this 95% confidence interval, we would have to reject H naught. So here I have the same problem. This is the one about the lifespan of conductors. So they surveyed 35 conductors. These 35 conductors have an average lifespan of 73.4, but the true human population of men has an average lifespan of 69.5 years. We know our population standard deviation and we know our alpha, okay? And this is our claim because we just said that the mean lifespan of conductors was different than 69.5, the mean lifespan of our population. And remember, we used a t-test in this originally. So I go ahead and I calculate my error. Remember, our error is our t alpha 2 times our standard deviation over the square root of n. This is how we calculated our error. Then we take our sample mean minus our error and our sample mean plus our error. This gives me an interval of 70.47, 76.33. Now, remember our mean of the men population is 69.5. Well, because we assume the population mean of 69.5 is not in this confidence interval, right? 69.5 is not in this range of numbers, we reject our H naught. So this is a lot of material to cover, okay? And I don't think you can digest it at one time. So I would keep going back over it until it gets clearer. I'll be posting more examples of hypothesis tests, and feel free to reach out to me for clarification. So just to recover what we talked about in this PowerPoint. We talked about the 3 different methods of testing, of hypothesis testing. There's the traditional one, there's p-value, this is my favorite, and then there's confidence intervals. So if our assumed population parameter is not in our confidence interval, we reject the null. And this might be this is a really nice one because this uses skills we already have in our tool set. We already know how to calculate confidence intervals. For our means, when sigma is known, everything's equivalent, right? You're going to end up always rejecting the null hypothesis no matter which method you use. If you're using a confidence interval and the interval is two-tailed, then just determine a confidence interval at that same level. So for an example, if the test is two-tailed and the alpha level is 0.01, you still find a 99% confidence interval. If the alpha level is 0.05, you still find a 95% confidence interval. If the original test is one-tailed, then the confidence interval needs to be at twice the alpha level. So for example, if the alpha level is 0.05, then the confidence interval needs to be 90%. If the alpha level is 0.01, it needs to be 98%. And this is because there's 0.5 or 0.01 in each tail, right? So if I have 0.01 in each tail, then I have a 98% confidence interval.